social anthropologist. I'm based in the Department of Archaeology and Anthropology at the University of Bristol in the UK. Cultural phylogenetics is when we take the phylogenetic methods that evolutionary biologists use to understand the diversity of species and their relationships they have with one another, and we apply those to cultural and linguistic populations. So we do this for a number of reasons. First of all, we know that human populations are related, human languages are related, and so we want to have a set of methodologies that let us bring that relationship into our analyses of cross-cultural variation. But second of all, phylogenetic methods, and especially phylogenetic comparative methods, are a really powerful toolkit for understanding certain kinds of evolutionary processes, like what are the rates of change of different types of cultural features, for example, or how can we infer what happened in the past given what we know about the present. So it's both a statistical methodology for allowing us to address a really important part of cross-cultural variation, and it's a really powerful toolkit. There are kind of two types of cultural evolution out there in the wild at the moment, and a lot of cultural evolutionary studies started by the importation of models from population genetics, understanding the behaviour of individuals in populations and the fate of their traits that they have. And analogous to this kind of microevolutionary level, what we're looking at is the kind of species level, if you like, of how social norms act in human populations. And so while we draw on these microevolutionary models about how individuals within populations are acting, we're trying to kind of step back a bit and think, well, it's not just that evolutionary processes are acting on individuals, but they're acting on human populations themselves. And so that's why we want to kind of bring in these ideas from macroevolution about diversity, for example, to see if we can use these towards explaining, the great variety of cultural and linguistic diversity that we see around the world. So it's a complement to different kinds of cultural evolutionary work out there at the moment. What's particularly new about it is what's old about it, actually. So in cross-cultural anthropology, we're bringing in these new methods, if you like, new to anthropology methods from evolutionary biology. But the kinds of questions that we're trying to answer are ones that have been around for a good 150, 200 years in anthropology, and they're very simple sorts of questions, like why do certain types of human populations who live a certain kind of lifestyle organise their societies in certain ways, and why do we see recurrent patterns pop up again and again? These are really old questions, they're not new ones. But what we're doing is we're using a set of methods and theoretical motivations that let us find the answer to those in a way that's both sensitive to the kind of anthropological nuances that we know about, but also controls for the fact that two societies might do the same thing simply because they've shared a common ancestor in the past. So it's the combination of the old and the new that's really the revolutionary thing, if you like. The field of cultural evolution in and of itself is kind of a really new adjunct, if you like, to extending evolutionary ideas. And while it's true that, for tens, dozens of years that people have thought that we can apply evolutionary ideas to culture, it's really probably only in the last 25 or so years that there's been a flourishing sub-discipline of cultural evolution itself that's started to build up an empirical data set that we can point to and say that we're starting to understand perhaps some regularities of things like the kinds of evolutionary forces that act within populations of human beings doing cultural things, for example, and how those kinds of populations themselves might transmit norms down the generations. So it's a broadening of both the data and the kinds of ideas that we can apply evolutionary theory and methodology to. I think we're all quite broad in our approaches, so most of us working in the field are happy to use tree models, happy to use network models, but it all really depends on the kind of question that we're trying to answer at any one point in time. And so, for instance, if we have a new data set of, let's say we're looking at a group of languages for which we've got some data about either their grammatical structures or their words, for example, and we want to do two types of things. We want to look at the extent to which those features look like they're vertically inherited and follow a kind of a tree model. But we also want to know something about the horizontal transmission in there, because in order to go on and use a tree that we might construct from that data, we have to be kind of sure that it's capturing the majority of the process that's going on there. If reticular evolution has been primary in the history of a group of languages, then attempting to impose a tree model on that is not going to get you very far. People for many years have thought that the Pacific was a sort of a natural laboratory for cultural evolution, because lots of small islands and a very big ocean. You'd think that the kind of migration processes of people spreading out and settling on different islands might produce a very beautiful tree structure without very much kind of hybridization. You might compare that to something like Indo-European, where people live on a continent, very, very long history of interaction and intermixing, and maybe language evolution might be a bit more reticulate there. It turns out that when we use some of these techniques that let us quantify the difference, it's the other way around. So Indo-European appears to have more tree-like structure. Polynesian languages appear to have more reticulation in their basic vocabulary. And we can think of various kind of social processes that might account for that. It might be that living right next door to your neighbour with the ability to transmit different cultural features might mean that you have more social forces acting to restrict this kind of transfer. Whereas if you've got a big ocean between you, you might be a bit kind of more free and easy about the kind of transmission of different aspects of culture and language. So I guess the point to take away from these studies is that we have to investigate these assumptions that we've got, and we have to investigate them with respect to each new data set that we have. A piece of work that I think really typifies how useful taking a phylogenetic approach, and here I am talking about a tree model, so is the work that I've done on inferring ancestral states of kinship in the Austronesian language family. So the Austronesian language family spans the Pacific, extends from Taiwan all the way up to the reaches of Polynesia, and it has about a 6,000 year history. And molecular anthropologists, so people using genetic data to try and understand this colonization history, have for many years used different molecules that tell different stories about how people have moved around in the Pacific Ocean. So mitochondrial DNA, for example, has told one story that the Austronesians came from Southeast Asia, spread through the Pacific very quickly, and didn't really intermix very much with people. Whereas the Y chromosome data, so this is a genetic marker that's transmitted through the male line, seems to tell a much more complex story, that maybe the Austronesian expansion was much older, for example, there was much more intermixing. And a number of anthropologists looked at these different results and said, well, perhaps it's the social structure of early Austronesian populations that could really account for this. And that's a good hypothesis, but it needs to be tested. So we were able to use phylogenetic methods to do this. So you can take a language tree, so this is a population history of what we know the relatedness between different languages is, and then you can plot on your data about social structure onto the tips of that tree and infer what happened in the past. So sometimes I call this virtual archaeology, because it's kind of like having a time machine. All you have is data that you know in the present, some idea of the phylogenetic relationships, and you can use statistical models to reconstruct what happened in the past. And we were able to do this for postmarital residence, which is the social norm that basically says where men and women move after marriage. And what we reconstructed was early matrilocal residence, which is a form of kinship where the newlywed couple go and live with the family of the bride. And this brings together these genetic results if we have matrilocal postmarital resonance. This brings men from disparate communities together with related women. And so, because one of the weird results that we've had in genetic data was that we had different stories being told by mitochondrial versus Y chromosome data. Finding that early Austronesian societies were matrilocal was a way to really resolve this. We didn't need to postulate that there were radically kind of different processes of migration for men and women, for example. It's just simply that the social structure produced a different pattern of genetic diversity for these different markers. But there's no way we could tell that. We can't go and dig something up that tells us about something as kind of ephemeral in the archaeological record as kinship. It doesn't really leave a trace one way or another in terms of material culture. So being able to use this statistical method and draw on just this ability to use a phylogeny and trace back in time meant that we could bring genetics, linguistics, anthropology all together, which, as someone with an interdisciplinary background, projects like that for me are kind of the gold standard of what we should be aiming for.